Hi, I'm Bob Tabor with LearnVisualStudio.net. In the previous lesson, I was able to hard code a geo-coordinate object and pass it to the map control in order to set its position, like you see right here on screen. However, for our app, we'll want to retrieve that information from the phone, not just hard-code it, okay? The Windows Phone API has a geolocator class that will use the phone's GPS system to determine where in the world it is right now. So here's the game plan for this lesson. We're going to experiment with our update map method to learn about the geolocator class, how to set its accuracy and obtain the current position. We're going to learn about other classes in the Windows Phone API that allow us to work with the map and the locale of the user. Then we're going to configure the Windows Phone emulator and set its position to a specific place, namely the John Hancock Center in Chicago. I have a special affinity for Chicago and for that building in particular, and I'll tell you about that a little bit later. So at any rate, we're going to pick up where we left off in the previous lesson. Let's go ahead and stop the running of our app, and we're going to focus on this update map helper method. And what I'm going to do is I'm going to add a bunch of code here, and then I'll explain what we're doing. First thing I'm going to do is just comment out what we've already done. And the intent here is for us to actually use the phone's current position to tell us the latitude and longitude and give that to the map rather than hard code it like we've done here. So let's go ahead and get started. Okay, so hopefully it's kind of obvious here what I set out to do. I'm going to create a geolocator class instance, and that will allow me to use the functionality in the phone to determine the latitude and the longitude. So we'll get return from this get geoposition async method a position, and we'll use that position to get the coordinates, the latitude and the longitude, and we'll use that to create a new geocoordinate. So essentially here we're having to convert from what the phone can give us to what the map needs. So that's why we're kind of changing from a geolocator to a geocoordinate. All right. So at this point I'd like to point out why we go in and set the desired accuracy in meters. Why do we need to set the desired accuracy? Well, the best article that I read on the process of acquiring the geoposition of the phone and why there are several factors to consider is this blog post that you see on screen right now. It's a blog post on the Windows Phone Developer blog by Daniel Estrada Alva, who was a software development engineer on the Windows Phone team. And so I will just kind of leave you to that, but it's not quite as straightforward as just saying, hey, give me an absolute position. There's several things to consider. All right. Next up, there's a keyword that you may not be familiar with here in line number 41, the await keyword. And if you'll notice when I typed it, I got some red squiggly lines and I hovered my mouse cursor over it, and I had to add this keyword async at the very top of this method in, let's see, line number 35. Just how this works and why it works and what's going on here, I'd like to save that topic for a later lesson. I promise you I will spend an entire lesson just on the await and async and task keywords, okay? So let's just hold on to that. For now, just understand that the purpose of this is to keep our application responsive while potentially long-running tasks are executing. In this case, the phone could take a long time to acquire the current location using its built-in GPS hardware. So while it's acquiring the location, the user's phone and even our app should continue to be responsive to the user's input. Again, more on that a little bit later, okay? So then, again, we're converting from this geolocator, getting the position, and then turning it into a geo-coordinate that can work with our map. The geoposition object has a collection of coordinates, as you can see right here. And the 2 coordinates, latitude and longitude, we pass those to create a new geo-coordinate, which we can give to the set view method now, along with the scale factor. And so when we run the app this time, you can see the result is that the map is zoomed into Redmond, Washington, the home of Microsoft's main campus. So this is the default position of the Windows Phone emulator, all right? And so that's why we're zoomed in here. So how do we change the emulator to use a different latitude and longitude? Well, if you recall, there is some functionality in the additional tools, and we can select the location tab, and I'm going to type in the John Hancock Chicago and then do a search, and it brings me to that position in Chicago right at the John Hancock Center. And so what I want to do is use my primary mouse button and add a pin right on top of the John Hancock Center. And you can see that it now gives us that latitude longitude of 41.8988 and minus 87.6231. Okay, great. And so by adding a pin, I've set the current location to the correct latitude and longitude for the John Hancock Center. However, sometimes it takes a while for the phone's GPS to catch up and refresh. And so what I found works the best is to exit out of the AroundMe app by hitting the Start button, and then go to the Windows 8 phone application list and go down to their Maps app. And I'll go ahead and say allow the Maps app to use the current location. And you'll see we start out in Redmond, but then we quickly jump way over to Chicago. Perfect. All right, and so now, once it's done loading, I should be able to go back to the Start menu, go back to our AroundMe app here in my application list, click the AroundMe app, and now even our AroundMe app will center on the John Hancock Center. Awesome. Okay, so great, it works. Just to recap, the big takeaway from this lesson is how to use the geolocator class to interface with the phone's GPS hardware to retrieve an instance of the geoposition class. The geoposition class has a number of interesting details, but for our purposes, we only care about the longitude and the latitude, which we can use to construct a new geocoordinate class, which is what the map control needs, so that we can set the view on that instead. And we learned how to configure the phone emulator's location to make it think that it's at a specific place in the world in order to test various location scenarios like we've done here. Okay, so that wraps up this lesson. We'll see you in the next one. Thank you.